Welcome. Today I will show you how to install Ampersand CFD, my OpenFOAM automation tool for your easy setup for OpenFOAM case directories. So a lot of people ask me how to install it, so I will explain in this video how to do it. So let's first go ahead and let's go to the Ampersand GitHub page here. This is the Ampersand page, and you can see the installation instructions that I added just recently. So here, you will need OpenFOAM, you will need Python 3.x. I've tested it using Python 3.8, 3.9 and 3.11, but I have not tested yet. And additional dependencies in the requirements file. And you will need OpenFOAM ESI versions, especially 2406 or 2312 or maybe even 2006 will work. So I will follow these steps to install it. First, clone this code to our directory. You can do wherever you want, and I will show it in this empty directory. So this is the test cd test directory, and then here I will clone it. I've already copied it, and here you can clone easily to your directory, and now you have this Ampersand CFD. But my Python has already installed the requirements, so I will use a new Python environment, Python env. I don't know which name, env. And it will create a new environment where we will install the required libraries. So it's finished. So, and to activate it, I will activate the environment and env environment scripts and activate. I think this will activate. So basically, we will need something like numpy and vdk, etc. And now, if you go into Python, there's no library because I just created. So we will install these now, and I will first go to the Ampersand CFD directory, and now I will install this pip install our requirements. Okay, I already downloaded, but it's very fast, but you will sometimes you need to download it. So the packages are already installed. Okay, and we just need to wait a little bit to finish this installation. Already downloaded, and then after that we will need to go inside. I will make it a little bit bigger. Go inside the Ampersand src directory and run this. Okay, I've finished the installation, so I've already inside the Ampersand CFD, so it means I need to change directory to src, and here we have a lot of files, and to run we need to use the main.py file, and we have two options. If you want to create a new case directory from scratch, you can use this python.mapy create. So I will copy this and paste it. Okay, let's see whether it's work or not. Okay, now you can see this Ampersand icon, and now we have this open dialog. So what we have to do is we have to select the project directory. So I will desktop and this to install. So I'll create another directory to test. Okay, and we have to show this text directory, and after that we'll need to give a project name. It will be the name of the case directory, or OpenFOAM case directory. So I have some provided some STL files, Ahmed body for external flows, and these inlets and outlets, walls, etc. For this is for external flow, internal flow. So I will first show you how to do the external flow problem. So I will give the name Ahmed test. Okay, and then the first thing I have to do is to choose the mesh. Mesh refinement, I'll go with a coarse mesh because this is just a demo. It will be really quite coarse, but if you go medium and fine, we will get a really good mesh. It will be fine enough to solve various parts of your problem, and it will be have a good boundary layers, I hope. So anyway, we just go ahead and we go and add an STL. It asks whether to add an STL or not. If you don't add, it will not add, but I want our STL. So here, if you type yes and enter, you will be asked to select a file, and I will find and open this Ahmed body STL file, open it, and then it will show you how to what you want to do with this STL. So the purpose is wall. If you have inlets or outlets boundaries as STL files, you can instruct as STLs, but for our purpose I will go with wall. So enter 1, which means the wall. Okay, so what it does is it will copy the STL to the project directory, and it will ask you if you want another STL file to the project. So I will say no. We only have one. I only want one, and internal or external flow is external, and it's the ground touching the body. It's useful for aerodynamics of automobile. If you have cars or Formula 1, whatever, your ground, it means your ground is touching the body. Yes. Okay, and you can choose the fluid properties, air or water, and you can just put other numbers to instruct whatever fluid properties you want to input. So anyway, I will choose one, which is air, and you need to define the velocity at the inlet or at the free stream. So I will give 10 0 0. This is a vector quantity, so in x direction, y and z directions. And transients or steady state, I will go with steady state. Number of cores per simulation for simulations 4. Half model, no. If you choose this, it will create only half of the model, which can save a lot of cells for your simulation and save a lot of time. But I will go with full for now, and it will analyze the STL and generate the domain size, and it will figure out how many layers. It chooses to have 3 layers. Okay, and it will show you the target y plus, which is 60 overall. There are some places which will have higher y plus values, and a lot of others will have lower values probably. But anyway, the y plus values based on the mesh size and the free stream velocity is 60. Okay, so it will ask you whether you want function objects for processing. So I will go with yes, and it will create a lot of function objects, etc. for your case, and you can just view the forces and residuals or mass flux, etc. In real time during your simulation. So if you yes, so it will create the project files, and we have this armored body, and we can just go ahead and see inside this test directory. So now we have this armored test, and we have this try surface, which is already copied, and we have other case files already created, and we are now ready to run the simulation if we want. But in this video I won't show you how the actual running, but I guarantee you it will run and it will generate good results if especially if you use medium mesh, and the coarse mesh is sometimes a little bit inaccurate. Anyway, this is the first feature. It's about the case directory creation, and if you want to change, for example, refinement, or if you want to add some STL file for whatever purpose, for example, you want to create a surface, a part of your STL which you want to refine, and you want to edit, you can easily do it in Ampersand, and I will show you how to do this. And to do this, we need to choose the modification part. So the code is here, python main.py, and we have to give an open argument. So input python main open, and it will open this open dialog again, and this time we need to open the case directory itself. So this is inside our case directory, and I will click select folder. Okay, and it will load the project and project found, and it will show the project paths, and it will give you a summary of the project name, and internal flow no, and on ground, yes, it's touching the ground, and transient no, it means it's steady state. And now we have this STL file, and we can choose to modify this whole case directory. So you want to modify the project settings, yes, I want to do something, and it will ask you what you want to do with this. So if you want to change the background mesh, okay, so here, this is the background mesh generated by the block mesh stick, generated by the Ampersand for your background mesh, and you can change these by yourself, or you can change through this. So I will show you how it works. The first, I want to change the background mesh, so I will input 1 and enter. So it will show you the current modification background mesh, and the domain sizes, which are here, these x, y, and z values, and the mesh size, etc. And if you want to change the domain size, or if you want to change the cell size, you can do this. So it will first ask you domain size change, maybe yes. Okay, I'll do this. And you need to add the x, y, z coordinates by yourself. So -4, these are minimum values, and these are the maximum values. I want to make a little bit longer, so -4 to negative y is -2.5, and negative 0.3. Okay, okay, I cannot do the set part because this is touching the body, so I cannot change this. And for the maximum parts, I can increase to 15, and y is 2.5 and z is 4 point, no, I think I need to change it a little bit, 2.5 2.9 and 4, so 5. Okay, domain size is changed. Okay, now you want to change the cell size, yes, and maximum cell size, so it will use the maximum cell size and recalculate these values by itself. So here this is the maximum cell size is 0.11 meters, and I want a little bit finer mesh, so 0.08 or 0.7. Okay, now this is already changed, so it increased quite a lot, and you want to modify another settings. Okay, yes, let's see what you want to do, and you can add geometry, so to add geometry. Okay, so it will ask you an new STL file for your geometry, and I have this Ahmed refine, which is the base of the body. You can use as a refinement region, refinement surface. So the purpose number is 5. Refinement surface, so it will ask you the refinement level. So I don't know the refinement level I should use, so I will check out the snappy hex mesh text a little bit, and this is a little bit of cheating, but okay, because this ampersand is designed so that you don't need to look inside these as much as possible, but the Ahmed body has level 3. Okay, we can already see this refinement. So the refinement level for this special refinement zone, so I will give it a 5, because the body is refinement level 3, so I want more. So the higher the number, the higher refinement levels, the finer your mesh, so I will give it a 5. And you want to modify another settings? No, I think I am good. No, and it will change the settings and rewrite these again. Now as you can see, it's changed recently, and if I reloaded this, you can see here this is the original Ahmed.stl, and now this is the guy I just inserted using ampersand, and here there's nothing changed, because this is not a refinement this will not be used as a wall. Instead, here it will refine the case, the surface by 5, and it will work. Okay, and also block mesh is changed, and here the new coordinates I've given are already set, and the new mesh size is changed. Okay, so if you run this, you will have much finer mesh, because I increased these things a lot. Okay, and finally, if you change something and you don't remember what you did here, you can see this summary a little bit, and I'm going to improve this for more complex solvers and more complex physics. So please stay in tune, and thank you for your attention. See you, bye bye.